This is IBM Museum, and this is a very impromptu video. It was caused by a Facebook friend putting this picture up. And this is what I normally pronounce it as PICMG. It's PICMG is what it's known as. And it's it means a backplane system. And then there is a board that is a single board computer, has most of the connections on it, that is put in one of these longer slots that you see with the black ISA slots to the back, and then those what look to be the same as white PCI slots to the front. And that's just where that card, basically with the CPU and all the other connections, we'll look at one of those in just a moment, goes through and plugs in. And I don't know why this backplane has two, and they're actually adjacent. I did think that the PICMG interface is only limited to one host card on the backplane. Now, these are done in applications that could be like an industrial application, somewhere where you have that PICMG card in there. That's all your processing. That's effectively the motherboard. And if it goes down, you had a spare, you just take out the one adapter and you plug it back in. And also for the fact that it gives a lot more adapter slots than a conventional system, conventional motherboard even. And even most of the functionality is on that single board computer. And you can have this mixed bus where so many, adapter slots of typically PCI or ISA. And then you have, in this case, it has, the backplane is powered. And you see even a keyboard port connector there. I mean, a lot of time the PICMG or PICMG, I'll just pronounce it as that for the rest of the video, have those, even a keyboard and mouse connector on them many times. And I'm a little bit more familiar with levels that had from a Pentium to even a slot 1 CPU on there. The whole assembly that even makes that adapter fairly wide where the CPU is, because it's perpendicular to this backplane. And then I've seen them up to like Pentium IIIs, and that's the level that I have tonight to kind of show. I did have this off to the side, and I'll bring that up. Now, I did want to go through and find just a little bit of prep for the video and find like a manual or something else, find some discussion online for what I have. And I found where they're sold. I mean, Amazon, it's currently out of stock. There's Walmart that was out of stock. There are places you can dig around for these that look like about $100 USD or a little bit more. And it's a nice little thing. I mean, if you have a backplane and everything else, some of the things to set it up, it can be a rather interesting computer in itself. And I'll go through to kind of follow up this video. Later on, I'll bring a system in that has one of these boards, and we can go through and even swap out the board and go to like a different drive setup and things like that. I did say industrial systems because that the backplane has so many slots. You could have like those multi-async adapters in there. Like I've got one that has 8 serial ports on one ISA adapter, and then I've got 4 boards in that system. I mean, that has so many serial ports on that system, and that would be like an industrial application for this type of board. Now, you'll see that it's labeled here, and this is the board that I have that I'm ready to show. you'll see it marked as an IBM, and it has an FRU, and this is just where they source this. That normally this is a Radisys, and it's called an EPC, and sometimes you see it expressed as a 2x25, and maybe some following letters and things like that. This being the 2325 level, that's seems to be the most common out there. And I even found a great GIF image of this board, but we're going to have the camcorder and going for to be able to show this. Let me go through and I'll bring up the let's bring up that camcorder in the background, and I'll be able to switch it. And so this is the board, and I can go through and I can, you know, hide my my internal webcam and get turned around to look at this a little bit. And this is the way it came to me. And this is not the box that it came in. Of course, it's very thick. And I'll get a lot of comments too to say, well, it's not in an anti-static bag, because I use the anti-static bag to send that Bermuda planer to Curious Mark, his YouTube channel, to get a PS2 Model 77 running. And so I pulled this out, and I kind of had this available, and yeah, I'll get it in an anti-static bag and to go through and protect it. But it's a nice little board, and yeah, there's a real good view of it before we get into the camcorder. And you can see lots of little connections on there. And of course it has a CPU. And I think this is like a Pentium III level. Could be, you know, Celeron too for socket 370. But it was like I think these are standard. It was like a 866 megahertz Pentium III. And of course an Intel chipset that would give a little bit more indication of what CPU that this could be on this board. I mean, I could even go through and pop the fan and take a look there, but I just don't want to disturb anything. And then I did have it where it came with these SIMs, and these are I think 256 megabyte DIMMs that are here. And we'll look at the speed probably when we get on the camcorder, and we can kind of do a little bit of close-up. So this would be 512 megabyte of RAM that would be on this board. And so let's get switched over, and I can do the little zoom in for the camcorder. Okay. That always looks dark on the screen for some reason. I think the videos come out right, but sometimes and I have the ring light on and everything else, and we'll get a good reflection of the ring light maybe for some of this. Now let's go through it also. I mean, that CPU and the RAM are very evident. All those little connections. We can look at the back, and there we have the even two network connections, and I think these are gigabit. That's why I say I wish I had a manual, but we'll go through. We plug in a system. I mean, I could even go through and decide if I'd install an OS on the drive to interface to this and have all the chipset drivers and everything else. We've got a single PS2 port, and that's a combination mouse and keyboard, and then the VGA port, and that's very low on the adapter. I mean, it has to be a case that handles that sort of thing with the backplane, the PICMG backplane being bigger, and allowing for something like that to plug in. You do see the coin cell battery on there for the configuration, and I think this even came with the battery. And yeah, let's get zoomed in. I can move it around. Panasonic battery. And I'll try and do the silk screen up as the board is. And it says, you know, use CR 2032, which that means basically a diameter and thickness of the battery, plus side up, if there's any question otherwise. And so and that looks like a BIOS beside it, probably. Just other support chips that are there, other headers. So let's go, and I mean at the very end, let's kind of look at, this is a Radisys, as you can see, you know, has a speaker there. All these caps look in pretty good condition. I mean, I wouldn't normally have a suspicion. I can probably go through and check those over, but none of them look bulged or anything like that. And then we see up here, we see it's marked as that EPC2x25. And like I say, that X normally be a 2325 for a lot of them. Radisys Technology, Ireland, Ltd. Barcode labels and things like that. The we determined, like I said, probably I think it's an 866 megahertz Pentium III, and this is PC133 RAM, and so effectively this means the CPU on this single board computer has a front side bus of 133 megahertz. So the clock multiplying to the CPU will be, it would be normally a multiple of that 133, and so it makes sense for that 866 megahertz CPU if that's the case. And it should be reported when, you know, this is in a working system and starting up. It should report what the speed of the CPU is. Now on the back, and this is where the IBM markings are. Try and figure out. Okay. Oh, there we go. See, there's the IBM FRU, and I didn't even find an IBM page on this. And there's a lot of data, and I even have a couple binders of the older industrial systems, including the PICMG systems. And so I've got extensive manuals and diskettes with drivers and things like that for those systems, but not so much of this one right off the bat. And that board, what they consider the SAR side, I mean, that's relatively, doesn't have any components or anything like that. And you can see, you know, pretty, some of those traces are pretty fine in some areas, and amazingly close to the ISA bus. The other, it just looks like a lot of ground planes that are on that level, and of course it's probably multi-layer board for being as elaborate as it is. I don't know how many layers, but getting flipped around to the other side, we have the support chips, and by the positioning of this chip to the CPU and RAM, this is going to be effectively the Southbridge chip. And I mean, even in this instance, old enough to where it doesn't require a heat sink. And let's zoom in. I didn't bring over my reading glasses. Let's try and zoom in. Okay. So that's the 815 chipset from Intel. Even has an S spec. The SL7UT is the S spec. And otherwise on the board, let's zoom out before we probably zoom back in again. Okay, so the chip effectively back here would likely be what they call the Southbridge chip. And that handles the slower items on the bus, where the Northbridge handles the faster items, is connected up to the CPU and RAM. And so for the Southbridge, there's that. And sometimes, or a lot of time, there's a different Southbridge chips that can be coupled with the Northbridge chip. And the Northbridge chip would be the heaviest indicator of what CPUs that is able to support. Now, we also have a national semiconductor chip here and some other chips. That's the national semiconductor lattice for probably some sort of ASIC or a high density chip of PAL or GAL that probably does a lot of the I/O decoding with as complex that it is. I'm still thinking that that's BIOS. And the national semiconductor chip, typically these are VE606RB. And then I don't know if that, it's probably more appropriate, that other marking, that PC87200 is probably a little bit more of the idea of what the chip is. And then we even see that other national semiconductor. And I wonder if that, that might be disk on, I don't see, and this is bad for silk screen markings in some of the areas. But that might be a disk on what they call DOM, like a disk on module or something like that. I don't know. And it's got this header that's unpopulated here, and I don't know what, what optional that might be. That might be a, I've seen boards that came over these for kind of a little daughter card attachment that did some stuff too. Now, kind of right side up, and those national semiconductor chips, they're close to, that's why I say they're normally I/O port chips, because towards the top, all this range of connections. We see primary IDE, and I don't see where it's marked as the secondary. And we'll kind of get back to the connections that's over on the right-hand side of that in just a moment. We have these sys 1 and sys 2, and I don't know, those are kind of like a fan style connection, CPU fan style, or like this one is for having that fan on the CPU and heat sink. So these may be drive power or something else arranged somehow. And they'd be 5 volt on one side, ground on the other side, and 12 volt DC on the other side. And probably not a whole bunch of current. The thought is, you do have the capacitors here on the one end of the board, mainly for just that CPU. But those could be, drive power. There is and I'm already getting gray beard hairs in here. I'll have to blow that. That's the diskette drive connection. Below it is marked as PAP, but that's probably a parallel port. Beard hair be gone. Yeah, there it's marked as floppy. Now, there's some connections here that I'll have to get in and get the right. Oh gosh, get the right orientation, get the right place, going all over the screen. Okay. So yeah, this is the SM bus for that white connector. And this other black connector, it is marked as GPIO. And so whatever, however they put the connector on that for, I don't know if that's kind of like a GPIB bus connection or something like that in that industrial side of things. These are COM ports, and I can probably, you know, once I get zoomed out to kind of show the positioning of where those are, or it was seen earlier in the video. And then above the one COM port, I don't know what that header is necessarily for. That's why it'd be nice to have a manual. There is a connector that's towards the, there's the Ethernet ports that are above in this case. And it's marked as LAN 1 and LAN 2 for those connections. And then that header seems to be marked as LAN LEDs. I mean, I could go through and get it. Get it upright in the correct way. So, and those are towards the back of the board. And then looking up in the corner, we have this, and this is marked actually as port 80 for that white connector. If I can, yeah, it's not, the 80 is not as visible on the camera as I'm moving it around. And so I don't know what kind of, if that's like a post code board that plugs into that, and that can give a little bit of indication on boot up of if something's going wrong. Standby power. There's also another, there's a jumper probably for the CMOS reset of setup and norm, you know, or normal mode. And there's those black connections, and they're marked USB 1, so you have at least 2 USB headers. And normally that's 5 pins. So, and there's some capacitors back there for the standby power and things like that too. But that's kind of a good going through. And of course I can go through and I can do a high-res photos of these and to kind of show, but that's kind of a big coverage, a lot of the connections. Now there's even, I don't necessarily know, there's probably some cases where this is like maybe a front panel connection maybe. And see, like I say, the silk screen is not marked really well at all. You see keyboard and mouse for the PS2 connector over there. And then you have the header there marked as ISP, 4 pins on one side and 3 on the other, and that may be some sort of I/O or front panel, like an in-service panel is what they're referring to, maybe, or something there. But that's a good view of just what connections the card has, what it looks like. And for a lot more details, that's probably going to be where I go through and get it in a backplane and powered up. Let me get, okay, I can get back on the screen myself and then turn on that webcam showing the board there. So, you know, it's, I'm sorry I didn't have a whole bunch more details other than looking over the board. A lot of the major connections are marked out, and, you know, probably with a little bit of study and knowing the awareness of these systems, someone could go through and figure out a little bit more of what they do. And I just want to get that down in a good position. I don't know what, a lot of time I leave it up to YouTube to give me a thumbnail, and who knows where that'll be, but that's probably a real good position. And, you know, just one of those off the wall content that I throw in from time to time. I do have lots of other content, of course, otherwise I can do, but this is just what come up on the plate tonight, and I ran with it. So if you enjoyed this video, go ahead and click on that like button, and by all means subscribe to my channel. Still gaining subscribers. I'm very happy with that. I'd like to get up to a much higher level. So recommend it to your friends if you can, but that's all I have for now. This is IBM Museum. Thank you.